We live surrounded by electricity. It powers every moment of our modern existence. Right now, as you read these words, electrons are flowing through the device in your hands. Electricity charges your phone, illuminates your home, keeps your food from spoiling, and enables nearly every convenience you depend on. It's woven so thoroughly into the fabric of contemporary life that we rarely pause to consider it. We flip switches without thought. We plug things in and expect them to work. We've become so accustomed to this phenomenon that we've stopped finding it remarkable, which is perhaps the greatest tragedy of the modern age. Because electricity, when properly understood, is one of the most extraordinary things in existence. Ask someone what electricity is, and you'll likely receive a vague answer. It's energy, they might say, or perhaps it's electrons moving. Maybe they'll venture that it's current flowing through a wire. These responses contain fragments of truth, but they obscure rather than illuminate. They take a genuine mystery and simply rename it, as if giving something a new name somehow explains it. But renaming isn't understanding. When we say electrons are moving, we haven't actually explained anything fundamental. We've only created a new question: what's moving them? And when we have moving electrons creating light or heat or mechanical motion, why does that happen? What's the connection between the motion of invisible particles and the visible effects we observe? The typical answers leave the core mystery completely untouched. The deeper truth is far stranger than most people realize. Electricity, in its essence, is something profoundly weird. Our educational systems have done an excellent job making it seem normal and comprehensible, safe and predictable. We present it as if it's just another well understood aspect of how the world works. But this is misleading. Once you truly see what's happening, once you pull back the curtain and examine the actual mechanisms at play, you discover that we're manipulating something absolutely extraordinary. We're channeling forces that break our everyday intuitions about how reality operates. We're leveraging principles that seem to violate the basic rules we think govern the universe. Let me demonstrate what I mean with a simple experiment that anyone can perform. Take a piece of plastic wrap, tear off a strip about a foot long. Now rub it between your hands with some vigor, as if you're trying to warm your hands on a cold day. Rub it hard for several seconds. Once you've done this, hold the plastic strip near the back of your hand, but don't let it touch. Hold it maybe a few inches away. Now pay careful attention to the small hairs on your arm. You'll notice something extraordinary. Those hairs are moving. They're standing up and reaching toward the plastic strip. You can actually feel the plastic pulling on you from a distance. The hairs on your skin are being attracted across empty air. Stop and really contemplate what just happened. You rubbed plastic. That's the entire cause. No batteries were involved, no electrical wires, no external power source of any kind, just friction between your hands and a piece plastic film. And through this simple action, the plastic has gained the ability to reach across empty space and tug on your body. From the perspective of your everyday experience, this shouldn't be possible. In the normal world you navigate, objects only push or pull when they're in direct contact. When you push a chair, you touch it. When you lift a book, your hands make contact with its cover. When you catch a ball, it presses against your hands. All the forces you experience in daily life require direct physical contact. Yet here is a piece of plastic not touching you at all, not even close, somehow exerting a force on your arm. When most people encounter this phenomenon, they shrug. Oh, that's just static electricity, they say, as if naming it explains it. We learned about that in middle school. It's not important, but this assessment misses something fundamental. What you're observing is not some trivial parlor trick or a curiosity without significance. You're looking at a demonstration of the electromagnetic force, one of the four fundamental forces of nature. You're witnessing its ability to act across a distance, to reach through empty space and influence matter. You're seeing the force that holds every atom in your body together. You're observing the force that makes chemistry possible, that allows your neurons to fire, that enables your muscles to contract, that permits your eyes to see. You're looking at the foundation of all biological activity, and you're dismissing it as unimportant. This is the core problem with our familiarity with electricity. We've become so comfortable with it that we've lost sight of how absolutely insane it really is. We treat it as mundane, as something we understand, when in fact we're surrounded by phenomena that are genuinely mind bending. Let me break down what actually happened when you rubbed that plastic strip. When you subjected the plastic to friction against your hands, you were scraping electrons off the surface of your skin and piling them onto the plastic. We're talking about an enormous number of electrons, perhaps a few trillion of them. These excess electrons don't simply sit there peacefully. Here's where things become strange enough to genuinely challenge your intuitions. Those excess electrons despise each other. They push away from each other with a repulsive force so powerful that the human mind genuinely struggles to comprehend its magnitude. Let me try to convey the scale of this. Imagine two electrons, the smallest particles you'd encounter in an introductory physics course. Place them 1 centimeter apart. The electromagnetic force between them is approximately 10 to the 42nd power times stronger than the gravitational force between them. That's a 1 followed by 42 zeros. To put this in perspective, the entire observable universe contains roughly 10 to the 80th power atoms. The electromagnetic force is so incomprehensibly more powerful than gravity that gravity might as well not exist, at least from the electron's perspective. For electrons, gravity is completely irrelevant, entirely meaningless. The electromagnetic force is everything. So here emerges a crucial question. If these electromagnetic forces are that monstrously strong, why isn't everything just exploding? Why doesn't matter simply tear itself to shreds? Why doesn't the universe collapse into chaos? The answer is almost magical in its elegance, and it reveals something profound about the structure of reality itself. The answer is cancellation. Consider what an atom actually is at its most basic level. At the very center, you have protons, which carry a positive electrical charge. Surrounding that nucleus, you have electrons, which carry a negative charge, positive and negative, plus and minus. And these charges follow one elegantly simple rule. Like charges repel each other, while opposite charges attract each other. The repulsive force between like charges equals the attractive force between opposite charges. The magnitudes are perfectly balanced. In ordinary matter, you get an extremely intimate mixture of positive and negative charges. Protons and electrons are packed as close together as the laws of physics allow. Every positive charge finds itself surrounded by negative charges. Every negative charge is surrounded by positive ones. And the result is that all the enormous repulsive forces are perfectly balanced by equally enormous attractive forces. The result appears neutral. The forces are still there, mind you. Those monstrous electromagnetic forces continue to act, but they're balanced with such precision that the net effect is zero. However, because the underlying forces are so huge, even the tiniest imbalance creates effects that you can actually feel. When you rubbed that plastic wrap, you moved perhaps 1 electron in every trillion away from your hands and onto the plastic. That's essentially nothing. It's negligible, but it's enough to make your arm hairs stand up and wave around. Because when the underlying forces involved are that enormous, even the smallest excess generates a noticeable effect. This insight completely transforms how you think about matter itself. Pick up a mug and hold it in your hand. What are you actually feeling? Your instinct is to say you're feeling the solidity of the ceramic, the physical substance of the cup. You're wrong. What you're actually feeling is electromagnetic repulsion. The electrons in your hand are pushing away from the electrons in the mug with enormous force. The reason you cannot push your hand through the mug isn't because the material is solid in some fundamental sense. It's because the electromagnetic forces are so strong that the electron clouds refuse to overlap or interpenetrate each other. Here's something that should genuinely trouble your worldview. Your hand never actually touches the mug. Not really. There's always a tiny gap between the atoms in your hand and the atoms in the mug. There's always space. When you think you're touching something, you're not actually making contact at all. What you're feeling is the electromagnetic force pushing back against you, electrons repelling electrons across that infinitesimal distance. And this leads to a realization that should completely restructure how you understand your own experience of reality. Every single force you've ever felt in your entire life is electromagnetic. Every push, every pull, every sensation of touch or pressure or resistance, all of it is electromagnetic repulsion and attraction acting across distance. You have never touched anything in your entire life. Every moment you believed you were touching something, you were actually feeling electrons pushing away from electrons through empty space. It's the same force you saw with the plastic wrap, just acting across smaller distances where the electromagnetic forces become so enormous that the effects become impossible to ignore. Now let's shift our attention to wires and think about how electricity actually travels through them. Picture a copper wire stretching through your house. At one end of this wire is an electrical outlet. At the other end is a lamp. You flip the switch, and the lamp lights up instantly. What happened? The standard explanation that most people learn is that electricity flows like water. According to this picture, electrons enter the wire at one end, travel down its length, and emerge at the other end. This explanation is entirely wrong. It's a useful metaphor for certain purposes, but it describes something that doesn't actually happen. Electrons in a copper wire move incredibly slowly at roughly 1 millimeter per second. At that speed, it would take an electron nearly half an hour to travel across a typical house. And yet, your lamp lights up instantly when you flip the switch. There's a major contradiction here. The actual explanation reveals something far more interesting than the water flow metaphor. The key insight is this: the wire is already full of electrons. Copper metal contains vast numbers of free electrons that are essentially sitting there, ready to move. When you close the switch, you create an electrical potential difference. This voltage pushes on the electrons at one end of the wire, but here's where the electromagnetic force's ability to act at a distance becomes crucial. Because electrons repel each other across distances, that initial push immediately affects the next electron in the line, which then pushes the next electron, which pushes the one after that. It's like a line of people standing shoulder to shoulder. If you push the person at one end of the line, the person at the other end feels it almost immediately. Not because the first person walked down the line, not because of any physical motion along the line, but because the push was transmitted through the crowd via a wave-like effect. The push travels through the wire at nearly the speed of light. This isn't because individual electrons are zooming through the wire at high speed. It's because the electromagnetic force acts instantaneously across distance. The signal of which way to push propagates extremely rapidly through the already crowded collection of electrons. That's what makes electricity useful as a technology. You can create a push at one location, and something can respond at another location miles away, almost instantaneously, across huge distances. The speed of the propagation is not limited by how fast individual electrons move. It's determined by the speed at which the electromagnetic force can transmit the information about what's happening. But we still haven't answered the deeper question: where does the original push actually come from? Let's trace it back step by step. Your lamp connects to an outlet in your wall. That outlet connects to wires running through your walls. Those wires connect to power lines, and those power lines connect to a power plant. That power plant might be miles away. It might be 100 miles away. And at that power plant, something is spinning. A massive turbine weighing many tons is rotating at thousands of revolutions per minute. That spinning motion happening miles away from your lamp is what's actually powering your light. How is this possible? How can rotation at a power plant possibly result in light at your home? The connection between that spinning turbine and your lamp is magnetism. And here's something that seems counterintuitive until you understand it properly. Electricity and magnetism are not two separate phenomena. They're not different forces that happen to interact. They're two different aspects of one unified force, the electromagnetic force. Moving electric charges create magnetic fields. Changing magnetic fields create electric currents. They're completely inseparable. You cannot have one without the other. Here's how a generator actually works. You take copper wire and spin it inside a magnetic field. The magnetic field pushes on the electrons in the copper. The electrons don't want to move. They'd prefer to sit there and maintain their positions, but the magnetic field is insistent. You keep the field moving, forcing the electrons to flow. That flow is electrical current. That's the fundamental mechanism. Motion plus magnets plus copper equals electricity. Now imagine running this process backwards. Take electricity, push it through a copper wire that's positioned inside a magnetic field. The magnetic field pushes on those moving electrons. The wire moves. That's a motor. The same physical phenomenon, just reversed. Generators convert motion into electricity. Motors convert electricity into motion. And the reason this works, the reason these devices are possible, is because electricity and magnetism are fundamentally unified. They're two aspects of the same underlying force. This should seem impossible when you first think about it. You're telling me that I can move metal in one location and other metal moves in a completely different location with nothing physically connecting them except thin copper wire? Yes. You're telling me that spinning a magnet near one copper coil generates a force that travels through wires and causes other copper to move? Yes, and we use this principle constantly, every second of every day. Every motor ever built, every generator ever constructed, every power grid on Earth operates on this single principle. Consider the path that electricity takes to power your home. Water falls on one side of a dam, releasing gravitational potential energy. The falling water strikes turbines, causing them to spin. As copper coils rotate inside magnetic fields, electrons are pushed. This electromagnetic force ripples through hundreds of miles of copper wire at nearly the speed of light. The electromagnetic wave reaches your house. It causes electrons to flow through the motor in your fan. Your fan begins to turn. Water falling in one location has caused a motor to spin in another location, miles away, connected by nothing but thin metal wire and the electromagnetic force that permeates the space between them. That's genuinely insane when you really think about it. We've become so accustomed to this that we don't even notice how extraordinary it is. You don't even need permanent magnets to make this work. Take a coil of copper wire, run electricity through it. The moving electrons create a magnetic field around the coil. Now move that coil close to another coil of copper wire. The changing magnetic field pushes on electrons in the second coil. Current flows through the second coil, even though there's no physical connection between them. That's a transformer. That's how the power grid works. You generate electricity at a power plant. You transform it to higher voltages for transmission. You transform it back down at substations. You transform it again for local distribution. The entire process operates on the principle of metal talking to metal across empty space using electromagnetic fields. Here's something that should completely reshape how you see reality. I mentioned earlier that all the forces you feel are electromagnetic, all pushing and pulling, all touching and pressing, all sensation of contact. But think about what that really means. The normal forces, the mechanical forces you experience every single day, the ones that seem fundamental and obvious, those aren't actually fundamental at all. They're consequences of the electromagnetic force. The electromagnetic force is the fundamental reality. Everything else derives from it. When you push on a door, you're creating electromagnetic repulsion between electrons in your hand and electrons in the door. When you walk on the floor, you're being held up by electromagnetic repulsion between electrons in your feet and electrons in the floor. When light hits your eyes, you're detecting oscillating electromagnetic fields causing electrons in your retina to move. Chemistry is electromagnetic forces between electrons and atoms. Heat is atoms vibrating because electromagnetic forces hold them in place. Biology is chemistry, which is electromagnetic interactions. Your entire sensory experience of the physical world is electromagnetic interactions. And here's something even deeper. You can't explain the electromagnetic force in terms of anything simpler. You can't say it's like a spring or like a rope because springs and ropes are made of electromagnetic forces. The electromagnetic force is fundamental. It's one of the four basic forces of nature alongside gravity, the strong nuclear force, and the weak nuclear force. You have to accept it as a brute fact about reality. You can't reduce it to something more basic. Everything else, all other phenomena, gets explained in terms of this fundamental force. This is uncomfortable because it means the electromagnetic force acts at a distance, and that violates most people's intuitions about how the world works. You've evolved to understand contact forces. Your brain is built for a world where things matter and they collide and they push each other. But contact is an illusion, it doesn't exist. There is no contact, there's only electromagnetic forces acting across very tiny distances. To truly understand electricity, to genuinely comprehend it, you have to rebuild your intuitions from the ground up. You have to accept that the universe is made of fields that permeate all of space. You have to understand that charged particles push and pull on each other across those fields. You have to recognize that action at a distance is the rule, not the exception. It's fundamental. Contact is the exception, and even contact is an illusion built on fields and forces acting at a distance. When you flip a light switch, here's the real story of what happens. You close a circuit. Electrons throughout the entire circuit start moving very slowly, about a millimeter per second. This movement is almost imperceptible. It's not what you're perceiving when you see the light turn on. What you're perceiving is something much faster. At the power plant miles away, a turbine continues to spin. Magnets rotate near copper coils. The changing magnetic field pushes on electrons. Those electrons push on the next electrons. The push propagates at nearly light speed through hundreds of miles of copper wire, carrying the electromagnetic signal across the continent. The push reaches your house. Electrons flow through the thin filament in your light bulb. The filament resists their motion. It's difficult for electrons to squeeze through that thin wire. That resistance generates heat as friction-like forces impede the flow. The filament gets hot enough to glow white hot. As the filament radiates heat, it emits electromagnetic waves. Some of those waves are in the visible spectrum. Those waves travel outward. Some of them hit your eyes. The oscillating electromagnetic fields cause electrons in your retina to move. Those moving electrons trigger chemical reactions. Signals travel through your neurons to your brain. You perceive light. Every single step is electromagnetic. The turbine spinning is electromagnetic forces. The signal traveling is electromagnetic repulsion. The resistance is electromagnetic forces. The light is electromagnetic waves. Your vision is electromagnetic interaction. It's electromagnetic all the way through. Think about how extraordinary this really is. 200 years ago, none of this existed. None of it. Electricity as we know it didn't exist in the modern world. Then humans discovered these forces. We figured out how to manipulate them. We built machines that could generate electricity, transmit it across vast distances, and use it to do useful work. In doing so, we completely transformed human civilization. We went from a species dependent on fire and muscles to a species that could create light whenever we wanted. Electricity gave us instant communication across continents. Telegraph, telephone, radio, television, internet, all of it electromagnetic. It gave us artificial light, cities that never sleep. It gave us motors and machines that could do work without requiring human muscle or animal muscle. It gave us computation, billions of tiny switches flipping on and off, all manipulating electromagnetic forces to process information. Every single aspect of modern civilization, every benefit you enjoy, every convenience you've taken for granted runs on electricity. And it's all based on this one fundamental insight. There's a force that acts across distances. And if you learn to manipulate that force, you can do things that would seem like magic to anyone from 200 years ago. So, what is electricity really? Electricity isn't a substance, it's not a fluid that flows. Electricity isn't an entity that exists independent of other things. Electricity is what we call it when we manipulate the electromagnetic force to do useful work. But more fundamentally, electricity is proof that the world is not what it seems. The world seems mechanical and solid, objects pushing against each other through direct contact. Matter that's just matter, bumping around. But that's an illusion, a misrepresentation created by our incomplete perception and intuition. The real world is made of fields and forces acting at a distance, particles pushing and pulling on each other through empty space, electromagnetic interactions defining the structure of reality. When you observe plastic attracting paper, you're seeing the fundamental force that makes chemistry possible. When you turn on a light switch, you're commanding electromagnetic fields that permeate all of space. When you really understand what's happening when it sinks in, everything changes. You realize the world is electric. You understand that forces genuinely act at a distance. You recognize that solid matter is just a carefully balanced dance of repulsion and attraction, a precise equilibrium maintained by electromagnetic forces so strong they defy comprehension. And you realize that humans figured this out. We discovered these forces. We learned to manipulate them. We built a civilization on top of them. That's one of the greatest triumphs of human intelligence. not just our capacity for computation or our engineering skills, but our ability to look at the world, recognize that it's fundamentally different from what it appears to be, and then harness those differences to completely transform our existence. So, next time you flip a switch, take a moment to consider what you're actually doing. You're not just turning on a light, you're manipulating fundamental forces. You're making electrons push each other across entire cities. You're converting motion to electromagnetic fields and back to motion again. You're wielding power over nature itself. You're using the same forces that hold atoms together that make life possible, that structure the universe. That's what electricity really is. Not a utility, not a convenience or a comfort, not just something that makes life easier. Electricity is a window into the fundamental nature of reality. It's proof that humans can understand that reality and manipulate it. That's the real story of electricity, not comfort, not familiarity, not convenience, truth.